So hopefully you watched the video earlier where we found the slope or rate of change for a table. We're actually going to use that exact same table for this one where now we write an equation for this table. So first off, you could start by, you could try and make it an equation for this in slope-intercept form, which is y equals mx plus b, but you have to get the y-intercept. That is not easy because look at this. We don't have a 0 for the x, which means we don't have a point on the y-axis that we can just sub the y-coordinate in for the y-intercept. And in this type of situation, point-slope form, another common form of line linear equation, is used. So what does that one look like? Well, it looks like this. It is y minus y sub 1 equals m times x minus x sub 1. It's kind of intimidating looking with the subscripts and the m's and the 2 y's and 2 x's, but it's really quite simple when it gets right down to it if you can get past the intimidation factor. First thing, this represents a line with slope m. No surprises there. M represents slope quite a bit, doesn't it? And it goes through the point x sub 1, y sub 1. That represents any point you want to use on the line. And that's another weird idea that you can just throw in any point into this equation. And somehow it makes an equation that would graph and go through all these points. All right, let's get down to work using this thing now. So I'm going to go over here and make a blank equation that we're going to fill in. Y minus y1 equals m times x minus x sub 1. And right under it, we're going to fill in and build our own equation. So how about a start? Let's go get that slope, that m value. So slope is defined again as change in y over change in x. For our table, we did this earlier, but since we found out that all of these have the same slope between all the points, we really only are going to have to show this for one. So this one, between this y and that y, goes up 5.58 units. And the x between the 2 points increases by 1.8 units. So when we do our change in y over change in x, divide those and you're going to get 3.1. That is our slope. Hey, let's plug it in. So here's our equation. Y minus, I don't know the y sub 1 yet, so I'm going to leave that, equals the slope. And for the m, and then it's x minus, and I'm just going to leave the x1, I'll leave a blank there and we'll fill it in a second. So what's our point? Y sub 1, x sub 1. Well, any of these on here are going to work. Any point in this table. I usually pick the simplest one. That's simple as in the eye of the beholder, but I guess this one looks neat. 1.5 is a non-messy number. Let's use this one as our x sub 1, y sub 1. So let's go down here. Now if I were to write it just as a point, it's going to be 1.5, 3.15, right? Close that parenthesis. That's the x coordinate here, right? So that one is going to be our x sub 1. This is the y coordinate, so that is going to be our y sub 1. And now all we have to do is plug them in. So let's take the x sub 1, 1.5. We'll stick it in for the x sub 1 here. Let's take our y sub 1, 3.15, sub it in for the y sub 1 here. And we're actually done. For a lot of students, this is uncomfortable leaving this as our equation because We've been subbing away like crazy. Shouldn't we put something in for that y and that x? Well, no. Remember, y equals mx plus b, that form, an equation of a line might be like y equals 2x plus 3. In order to graph it, it has to look like this. There's a y and an x in there. There should be a y and an x in here. And if you want to test it because you don't believe me, go to Desmos and key this sucker in right now. It's going to make a nice little line. You could even put some of these points into Desmos, and you're going to find out that that line goes through all of these points, because that's how we built it.